Hello there everyone, today we will be talking about llama.ttf. Llama.ttf is a font, it's also a large language model, and it's in fact also an inference engine for that large language model. So if it's not really clear how all of those three things fit together, you're in the right place. Tune in for the rest of the presentation and we will find out how this makes sense. So here we have it. llama.ttf, the font to end all writers blocks. So in this little presentation, we'll be looking at the biggest questions in the universe. Those include, why are large language models so hyped in the first place? Several $billion are being poured into this industry. And it's maybe not so clear why. We'll see a few examples of how this makes sense. And we will talk about what letters are. That's an even deeper question. And at the end of it, we might even talk about some of the deepest questions there are. So many of you will know that the act of putting generative models into typesetting is not always a good idea. You'll see an example where the AI will mess up, but those cases generally stand alone. There's more prior art out there. One good example, probably the prime example of the usefulness of large language models was recently published by a fellow named Tom Seven, who shows that large language models can be used to format text. So it ends up looking nicely. And inspired by that, we will move forward and see how the text, the font itself, could be used for such purposes. And so picture you. This you're a struggling writer. You're trying to write a children's adventure book, but you're simply not getting anywhere. You're trying to figure out what on earth could it be wrong with this. So you move to the internet, you search, you say, okay, what could possibly be going on here? The first thing you come across is writers.com, which tries to explain writer's blocks and how they occur. So you'll come up with several possible suggestions. One could be that you're feeling constrained by the system. There is something wrong with the act of writing itself. Other examples include that you're seeking external validation, that you're not feeling good enough, that you're feeling afraid. The three last ones are a little uncomfortable. They're all about facing your inner demons. So they are probably not right. We must go to the first one instead. This is the system that is wrong, presumably. So that's what we will be doing something about. So you are blocked by the rules of writing. So the obvious question is, well, what is writing? So writing is the act of creating a persistent representation of human language. It's not so clear what that means, but it's pretty clear who the main culprit is, who our main antagonist is. It's the font. If we can somehow fix the font, then we should be in pretty good shape. So that's what we'll be doing. So what is actually the issue with fonts? If you think a little bit about it, fonts, they're generally not very inspired, you could say. And at the same time, they're also not very efficient exactly. And they're certainly not very clever. I don't think anyone can name an example of an intelligent font, not before this presentation anyway. So let's just try and see in a little demo what the sort of issue that we're having here is. So you'll fire up your favorite editor. I'm using gedit because being a struggling writer, this is all I could afford. And so you'll generally want to pick a font that seems like it does a good job. Let's take something with tech that seems like it's good. So we'll be saying, okay, once upon a time, and you'll be moving on. You won't get anywhere. The font here is simply too boring. So that's the question. Can we somehow do something about this problem? Coming back to the presentation. Well, if you think a little bit about it, why are fonts doing such a terrible job? Well, it's because they actually have a very, very hard job. They're trying to do more than they should. So a good example of that is the so-called ligature, which is what happens if you take separate letters that you would actually like to look differently when you put them together in writing. So a good example here is FI. You might want that to be written as this ligature right here. So figuring out how to shape these letters in a way that looks like you would expect turns out to be a very difficult problem. So luckily we have libraries that do this for us. So one prime example of that is the library called Harfbuzz. It's a text shaping engine. It does exactly what we just talked about. It shapes text. It's included in a lot of open source libraries. You may know of Chrome, Firefox, and also gedit that we were looking at just a moment ago. And here's an example of the sort of thing you can do with it. You can take a bunch of dots and you can move them into a different position. That would be an example of moving glyphs around. I think they're called eclipses ones. Maybe something entirely different. I'm not, in fact, an expert on fonts, as you'll know by now. We will, so we'll be using this this font shaping engine for the remainder of this presentation to come up with our own fonts. So in doing so, we'll notice that the way that Harfbuzz solves this problem in this particular case is by including in the library a virtual machine, which can run WebAssembly. This in turn means that they can run any calculation that they need. In particular, they can use a calculation to shape the text that they need, but they can also in fact run any calculation. So that's what we will be doing here too. So let's get back to our demo. We will we'll start out by investigating a little font that we made. It's called llama.ttf. And so we'll just immediately change to that. Llama, that's probably under L, you would imagine. L, no, it's not there. It's probably under L. L starts with, it starts with an O, right? So yeah, here it goes, right after N. There we go. Llama sans regular. That's what we'll use. Good stuff. It says open sans regular here, slightly suspicious. So we can start using this font. We can say once upon a time. So, okay, so the first thing that you'll immediately notice is that we can use the font to correct all O's, so that all O's have slashes through them. I did, in fact, just type the letter O on my keyboard. So we do that because that's just right. You might think that it's a little suspicious, that this looks an awful lot like open sans. In fact, is this just open sans? No, of course not. This is llama sans. Wait, was that open sans? Oops, I crashed the thing. I'm not supposed to do that. Let's try again. Was that just open sans? There we go. Much better. So if you don't really like the fact that it does this, and if you indeed think that, you know, it would make more sense to have your O's like they should be, since we're doing children's adventures books by the end of the day, one nifty thing will be to have a magic word that we can use. So the magic word in our case is abracadabra, which using that, you know, fix up your font so it looks a little bit more like you're used to. So mess up the magic word and everything will go back to the way it was just a moment ago. So so that's great. Now we have a better font, arguably more efficient. Is it also more intelligent? Maybe not, because we still sort of have the same issue, that we still have to write the children's book, and that's not really what we want. So so the idea here is that we don't have to. This is an intelligent font read, so all you need to do is you need to yell at the computer. One downside of artificial intelligence is it becomes sentient very quickly, and the only way to control it is to yell at it. So so that's what we do. We say once upon a time. We give it a lot of the buffering space, so we put in a lot of exclamation marks. And the reason we do this is so that it doesn't crash like it did just a moment ago. And then sooner or later, the computer will start. There we go. It will start running the WASM, the WebAssembly, through the little virtual machine that it comes with Harfbuzz. And in our particular case, what the WASM does is that whenever we put in another exclamation mark, it will generate text based on what we wrote before. So it will complete our little story here. So if this is a little unclear, again, I am simply typing exclamation marks, and my font here, on every iteration of that, generates more text. So to illustrate how that works, we could take our text here, could put it into a terminal, for instance. So I am in fact just writing once upon a time. I could also take my font here, and I could change to a different one, maybe like open symbol. Oh, that's probably a terrible idea. Noto sans. And this is what my text looks like. It is once upon a time, but in fact, in a font that happens to include a large language model and an inference engine for that. And so there you go. That's the same text, but in a different font. Clearly, something that investors should pour billions into. So if that's something you want to do, we can look into that afterwards. So knowing all of that, now there can be no possible writer's block, because whenever you put in a letter, in particular the exclamation mark, then the writer's block will just fix itself through the font. So that's exactly what we intended to do. So in particular now, writers and fonts can live happily ever after. Just look at its happy little font face. So you might wonder, is this actually a good idea or not? It's probably a terrible idea for several reasons, some of which we can go into now. But then on the other hand, the governing rule of business these days is that things cannot really be taken serious if you don't put AI into them, and that also includes fonts. So is this a good idea? Well, we can start comparing to other reputable font families out there, including something like Comic Sans. So one upside or a downside compared to how you look at it is that a file like Comic Sans takes up 89 kilobytes, whereas if you want to include a 70B inference model into a text file, into a font file, you will end up having a 280 gigabyte font file, which might be is probably not good for your personal web page necessarily. And there are some other things, some other drawbacks that you might want to consider. So remember what we're actually doing here. We are pretending that the long sequence of exclamation marks is something that should be parsed as, think of it as a ligature. So when you have 70 exclamation marks in a row, the font should look in a particular way. Well, one downside with that is if we put it on two separate lines here, see if this actually works, then the exclamation marks will also be on separate lines, because my initial prompt, once upon a, is part of the very long ligature that I'm having here. So by putting this into separate lines, it will in fact no longer parse. Could be a feature, I don't know. But then on the other hand, this is also a font, right? So let's try and do a different example. Let's take everybody's favorite graphics editor called GIMP. It crashed recently. I wonder why that is. So we could do some of the same examples there. Let's see what we can do. So we could say once upon a time. For some reason, it's not really in a hurry to do that. It's probably just loading everything. There we go. Yeah, once upon a time. So that looks kind of boring. Still just loading. So excuse my very slow machine. Again, writer's blocks. You can only get so much hardware. I think we can probably just force it to be more responsive like that. There we go. So so that was the wrong font. We want to use Open Sans. It was actually called Llama Sans before. It's called Open Sans in this editor. A little bit suspicious again. And in Open Sans, this looks like you would expect. So let's go back to our font there. Let's also make it a little bit smaller. It's probably a good idea. Hopefully you can still see what's on the screen. Now we can take our text from gedit. We can copy and paste, so you know what's going to happen when I copy and paste this text. I'll get a lot of exclamation marks. Got a little bit too big again. Let's see if we can fit them on one line. 26 should do. But again, this is the wrong font, right? We don't really want this font. So here we can use Open Sans, which is the font that we hacked to obey our orders here, or really the orders of the large language model. And what just happened there was just by running, changing the font behind the hood, the large language model inference engine ran again, because this is all embedded in the font. This is nothing about gedit or GIMP for that matter. So we have a large language model inside a font. I don't know. I mean, again, feel free to send billions my way if that's what you want to do. Won't force you. But there you have it. That's llama.ttf. It's a font which is also a large language model, and which is also a inference engine. All right, thank you everybody for watching. Hopefully it makes more sense now.